August 28th. You know, it might just seem like another late summer day on your calendar, but in the realm of mathematics, it is an absolute goldmine. Today, in our explainer, we're diving into exactly that. We're going to uncover how three totally separate events, all landing on this exact same day, fundamentally built the modern, high-tech world we're all living in right now.
We are traversing across completely different centuries and entirely different continents here. We're talking 1801, 1913, and then jumping all the way forward to 1938. We're going to meet three brilliant minds who actually shared a birthday or a fateful day of passing on August 28th. And the crazy thing? Each of them solved a seemingly impossible, chaotic problem that directly powers the tech and the complex systems you're literally using at this very moment.
So let's start with a mystery that we interact with every single day. How do businesses actually know exactly what to charge you? I mean, whether it's a $5 artisan coffee, a brand new $1,000 smartphone, or an airline ticket, it is definitely not guesswork. How do economists and corporations map out what we want and anticipate exactly what we're willing to pay before we even know it ourselves?
Well, the answer to that actually takes us all the way back to France. Born on August 28, 1801, Augustin Cournot was a man remarkably ahead of his time. He was a true pioneer of mathematical economics. While everyone else back then just saw commerce as this unpredictable emotional art form, Cournot, he saw a massive machine governed by invisible laws. He dedicated his entire life to mapping out exactly how money moves and how markets truly function underneath it all.
Cournot didn't just watch the chaos of buying and selling. He literally tamed it using calculus. He was actually the very first person to express supply and demand as concrete mathematical functions. By exploring really advanced concepts like marginal cost and oligopoly competition, he laid down the exact algebraic groundwork that modern corporations still use today to optimize their pricing. He essentially took totally unpredictable human behavior and turned it into a highly predictable math equation. So the next time you wince at a shockingly high price tag for your morning latte, just remember this. Every single price tag you see is secretly driven by mathematical patterns. And it was a brilliant 19th century Frenchman who first wrote the underlying code making modern corporate pricing possible. The math he pioneered over 200 years ago is literally dictating what leaves your bank account today. Pretty wild, right?
But the magic of August 28 absolutely does not stop in the early 1800s. Not even close. Let's jump forward exactly 112 years to 1913. While Cournot's economic theories were taking root globally and completely reshaping international markets, a totally different kind of mathematical revolution was coming to a close, one that would eventually build an entirely new digital reality that we completely take for granted today.
Think about your favorite massive open-world video game, or the last time you strapped on a virtual reality headset. How do computers, which, let's be honest, at their core really only understand flat ones and zeros, how do they know how to build incredibly complex, explorable 3D worlds? How do they successfully translate just a string of flat data into an immersive, believable physical space that you can actually walk around in and interact with?
For that, we've got to thank Alexander Macfarlane. He was a brilliant Scottish mathematician, logician, and physicist, and he passed away on this exact date, August 28, 1913. See, while Cournot was obsessed with mapping human markets, Macfarlane was utterly obsessed with mapping the unseen rules of physical space itself. He was laying the groundwork for digital worlds long before the very first microchip was even a thought.
Macfarlane was a pioneer in a field he called space analysis. He helped develop advanced vector algebra and adapted complex numbers, specifically stuff related to quaternions, to accurately represent rotations in 3 dimensions. What does that mean in plain English? He basically figured out how to take physical 3D space and turn it into a rigid, calculable system of numbers. He successfully unified disparate branches of math just to map out physical realities.
It's a real mind-bending paradox when you stop and think about it. The immersive 3D graphics and sprawling digital architectures we play in today were actually mapped out by a mathematician over a century ago. The cutting-edge digital future of gaming and virtual reality relies entirely on the complex geometric algebra established by a guy living in the early 1900s.
Okay, keeping with the unbelievable serendipity of our golden date, we're going to jump forward another 25 years to 1938. We're leaving Europe entirely behind and moving to a completely different continent for our final story. And this brings us to a mathematical breakthrough so incredibly powerful, it arguably holds the key to the sustainable future and survival of our entire planet.
We are currently facing a massive, truly urgent modern challenge. How can we efficiently capture the raw, unyielding power raining down from the sun and convert it into clean energy that lights up our cities and homes? Moving away from fossil fuels to harness renewable solar energy isn't just a nice-to-have anymore. It's arguably the most critical engineering and survival hurdle of our modern lifetime.
The foundational math required to answer that incredibly complex question leads us straight to Alexander Animalu. Born in Nigeria on August 28, 1938, he grew to become one of the most remarkable theoretical physicists of his entire generation. His advanced mathematics and his incredibly deep understanding of the physical world directly paved the way for the vital sustainable technologies we rely on so heavily today.
Animalu's work in solid-state physics is absolutely legendary. He made massive breakthroughs in theoretical physics and superconductivity. By authoring highly influential papers, specifically exploring how metals screen electrons using something known as the pseudopotential concept, he essentially modeled exactly how materials conduct and transfer energy at an atomic level. He pioneered the mathematical application of physics that makes modern, highly efficient solar energy capture possible.
Which brings us to our final, incredible realization. When you look up at the shiny solar panels powering our modern homes, you aren't just looking at sheets of glass, wiring, and silicon. The solar panels powering our homes literally run on the advanced math of superconductivity. The clean energy surging through those panels is behaving exactly according to the mathematical laws Animalu so elegantly defined.
3 incredible minds, 3 different centuries, 3 massive foundational shifts in human history. When we bring all these historical dots together, the true connection is just undeniable. From Cournot modeling unpredictable human markets, to Macfarlane digitizing physical space, to Animalu harnessing raw stellar energy, the underlying through-line connecting these 3 men, born or passing on the exact same day, is absolutely incredible.
Every single person we met in this explainer looked out at the overwhelming, intimidating complexity of the natural world and asked the exact same question. What is the mathematical pattern hiding inside all this chaos? And because they dared to ask, they successfully transformed the raw, unpredictable chaos of human markets, physical dimensions, and solar energy into the structured, modern order of our global economy, 3D technology, and clean power grids.
Because they asked those questions, our world today is fundamentally different, more connected, and vastly more advanced. So as we celebrate the legacy of August 28th, it leaves us with one final provocative thought. As you look around your own life, what hidden patterns are waiting to be discovered today to build the world of tomorrow? Thank you for joining me for this explainer, and I'll catch you next time.